To make more sense of multi-layer communication, let's take analogy. So imagine two philosophers. The third layer, this is the top layer, two philosophers. Basically it's called the peer processes. This is, we'll consider it as a layer, third layer, layer 3. See, you can see the number, layer 3. So two philosophers, one of whom speaks Kannada and English, that is Sadhguru. He knows only Kannada and English. And the other philosopher who speaks only Chinese and French. Okay, and this is the top layer. We are taking an analogy. This is a top layer. We can call it as a peer process layer, and the layer name is layer 3. Okay, so now since they have no common language, they each engage in they each engage a translator. So here we have a translator, and this is the layer 2. This is also peer process, and then a layer 2 we have a translator. So layer 3 and then a layer 2. Two layers. Then each of whom in turn contacts a secretary. So this is a layer 1. So total this is a 3-layer architecture, a 3-layer communication. Let's see how it happens. Now let's try to transfer a message and we'll see what's going to happen. Now what is the problem here? Because philosopher one, Sadhguru, he wishes to convey a very very important message to his peer about yogic karma or karma yoga. To do so, he passes if he passes in English. Is it possible for a guy who does not know English and Kannada to understand what he was saying? No, it's not possible. So that is the reason we are using a multi-layer communication process to transfer the data safely, securely, and understandably. Okay, so now here the philosopher one, that is Sadhguru wishes to convey a message about yogic karma. For to do that, basically he knows Kannada and English, so he preferred the English. He passes that message in English. So now across this interface, the 3 2 interface, uh, through this interface he has passed that message, and then it has reached the translator saying yogic karma. Okay, so the translator received this message as yogic karma. Now the translators have agreed on a neutral language known to both of them. So both of them neutral language is French, so they chosen a French. So the message is converted to French, that is karma yogiki karma yogiki karma yogiki. So the choice of the language is the layer 2 protocol. So what is the protocol that we have used in a layer 2? It is the choice of language, and is up to the layer 2 to decide the protocol. So here, through the 2 and 3 interface, yogic karma, the English message has came to layer 2, and layer 2 has a protocol. What is the protocol? Protocol is to translate this English into a common language, that is French. That is the protocol. So this has been executed here. Now the translator then gives the message to a secretary for transmission, for example by email. So now it has reached to the secretary, and the secretary has to send it through email. So here that's the one, layer 1. So after the layer 1 is going to use a physical layer called email, and through that is going to sell, he is going to send it. So fax, and then at the rate of karma yogi key. This is in French. So that's the layer 1. So now when the message arrives at the other secretary through the fax, basically that's the uh, physical device that we have used. uh, once it passed to the Once the message arrives at the other secretary, it is passed to the local translator. So you can see this step. The message has reached the layer 1 of the uh, host 2. So here now this guy, what this guy is going to do is, this guy is going to pass that message to local translator, which is in French. So then the layer 2 of the host 2 is going to translate that into French and passes it across the 2 by 3 interface to the second philosopher. Note that each protocol is completely independent of the other one as long as the interfaces are not changed. The translator can switch from Dutch to Finnish. So they can choose whatever language that they want, but they have chosen this. So both has preferred a French. Here the protocol is French, and after that, once this guy received that message in French, then he has converted that into Chinese and he has sent it to this guy. So they can go for the common language Dutch or Hindi or anything, but finally the second translator has to he will convert this into the language which is understandable by the this French or this philosopher. So similarly, the secretaries can switch from email to telephone without disturbing, even informing the other layers. So each process may add some information intended only for its pair. This information, the final motto is the information should be passed up to the layer above. That's what the final motto is. The similar way our even the computer based network also works. So now we will look into the actual computer based network. So this flow, uh, the flow which you are going to see only supports a virtual communication and layer 5 layer virtual communication. Okay, so now consider a more technical example. So how to provide communication to the top layer of the 5 layer network that you see in front of your eyes, that figure you can see. Okay, first let's begin. We have two machines. One is source machine and destination machine, and we have 5 layers. It's a 5 layer architecture. So now let's begin. A message, capital M, is produced by the application process. So the source machine has some WhatsApp or some that sort of application, and that application has produced a message, a message, uh, and it will be passed or it will be given to the layer 4 for transmission. Now a message, now a layer 4 puts a header in front of the message to identify the message and passes the results to layer 3. So the header actually includes the control information such as addresses to allow layer 4 on the destination machine to deliver the message. If you take a few more other examples of control information used in some layers or sequence numbers. In case of the lower layers, does not preserve the message order and sizes and times in, and these are some other examples. And in many networks, no limit is placed on the size of messages transmitted in the layer 4 protocol, but there is a nearly always a limit imposed by the layer 3 protocol. So now the message with the header has been added, and then it will be passed to the layer 3 protocol. So consequently, layer 3 must break up the incoming message into smaller units. It's called packets. So prepending a layer 3 header to each packet. In this example, M is split into two parts, that is M1 and M2, and that will be transmitted separately. So layer 2, then it will go to the, then layer 3 decides which of the outgoing lines to use and passes to the packets to layer 2. So now layer 2 adds to each piece not only a header but also a trailer, and gives the resulting unit to layer 1 for physical transmission. And finally, we are at the we will go to the physical layer. So all this data with the header and trailer and then main message will be transmitted through the physical layer to the destination side. Now at the receiving machine, the message moves upward from layer to layer with the headers being stripped off as it progresses. None of the headers for layers below n are passed up to the layer n. So here the same thing repeats. Here header and trailer will be stripped off. Only message will go up with the S3 and S4, and then once it reaches to layer 3, here adders, one adder will be stripped off, and then message, or the main message, because the main message will be broken into pieces now, so that will be accumulated into single message and goes to the layer 4. And then here it's header and then layer, the control information, and then main message will be there. After that, that control information will be stripped off, and then only message will be sent to the application. That's how a WhatsApp application works. That's how a message that you have typed will follow all these layers and finally get back to your girlfriend. When you say I love you to your girlfriend or to your mother, so that is the way it goes from your application. That's a layer 5. Then we'll have a layer 3, layer 4, layer 3, layer 2, and then you have a physical device or physical transmission device. Through that, again it passes through layer 1, layer 2, layer 3, layer 4, and finally get back to the application. That's a layer 5, where your mother can see, okay, my son said I love you. So the important thing to understand about this figure is the relation between the virtual and actual communication, and the difference between the protocols and interfaces. The peer processes in layer 4, for example, conceptually think of their communication as being horizontal. Using the layer 4 protocol, each one is likely to have procedures called something like send to other side or get from other side, even though these procedures actually communicate with lower layers across the 3 by 4 interface and not with the other way around or other side. So the peer process abstraction is crucial to all network design. Using it, the unmanageable task of designing the complete network can be broken into several smaller and manageable design problems, namely the design of the individual layers, that we are going to see in coming forth slides.